All right, let's just jump right into this explainer. Today, we're going to peel back the layers of what I think is absolutely one of the most fascinating objects in the entire night sky. We're talking about a structure that's not only hauntingly beautiful, but also insanely complex.
So let me ask you, have you ever seen a ghost floating out there in the deep depths of space? I know, it sounds totally like science fiction, right? But today, we're actually hunting down a very real cosmic apparition. It's an object so ethereal that early skywatchers literally thought they were looking at the spectral reflection of a familiar planet. And here is our target. Meet Caldwell 59, or as it's famously known, the Ghost of Jupiter Nebula. Just look at that mesmerizing pale blue elliptical disk. It was originally discovered way back in 1785 by the legendary astronomer William Herschel. When he looked through his telescope, that faint blue disk actually reminded him of the planet Jupiter. But, as we're going to see, modern astrophysics paints a way more violent and honestly a much more spectacular picture.
Now, to really put this into perspective, we need to talk about the number 4,000. Because this breathtaking stellar monument is located a staggering 4,000 light-years away from us, hidden away in the Hydra constellation. That means the light we're seeing right now has been traveling across the galaxy for 4 millennia.
To truly understand how this whole phenomenon works, we're going to treat this explainer like a cosmic anatomy lesson. We'll be looking at 1. Meeting the Jupiter ghost. 2. The anatomy of a nebula. 3. Mysterious jets and knots. 4. The blistering X-ray bubble. And finally, 5. Rings in the halo.
All right, let's start with Section 1, Meet the Jupiter ghost.
So, right off the bat, let's clear something up. Even though it's called a planetary nebula, it has absolutely nothing to do with planets. None whatsoever. It's actually the spectacular end-of-life phase of a star. You see, when a star roughly the size of our own sun runs out of fuel, it doesn't just quietly fade out. Nope, it puffs up, gets super unstable, and violently expels its outer layers out into space, leaving behind this giant, glowing, ionized envelope of gas.
Moving on to Section 2, Anatomy of a Nebula. So how does this complex shape actually build over time? Well, it all comes down to what astrophysicists call interacting stellar winds. Basically, first, the dying star ejects this slow, incredibly dense wind over tens of thousands of years. Then, much later, the exposed core of the star fires off a newer, ridiculously fast wind. When that fast wind slams into the older, slower wind, it acts almost exactly like a snowplow, sweeping all that material up into a really dense, beautifully structured shell. And you can really see the sheer contrast between these two stages. On one hand, you've got this massive, diffuse outer halo, which is that older, slower material. And then, boom, right in the middle, you have that sharply defined, elliptical inner shell. And get this, it's actively expanding outward at about 25 kilometers per second. It's literally a shock wave, frozen in time, glowing right there across the optical spectrum.
Which brings us to Section 3, Mysterious Jets and Knots. As we zoom in past that outer shell, we start to encounter some truly bizarre and chaotic structures. You'll notice these strange, isolated spots that look almost like glowing knots of gas, just sort of hanging there. But they are definitely not just floating. Embedded deep within the nebula, astronomers call these formations ansae, or fast, low-ionization emission regions.
Now, usually we just call them flyers. And these incredible jets are rocketing through the nebula at over 100 kilometers per second. That's just wild. Plus, they're strongly oriented in a very distinct northwest-southeast direction. This tells us they were likely fired off by a powerful, highly focused ejection event from the dying star. Kind of like a massive cosmic cannon just firing twin projectiles straight through the surrounding gas. But here is the real kicker. Recent data from the MUSE instrument picked up a very specific atomic carbon emission coming exclusively from these knots. And honestly, this totally blew astronomers' minds. It strongly hints that, despite being absolutely blasted by intense radiation from the dying star, these knots might actually be sheltering surviving super dense molecular cores right in the middle of this hostile environment. It's literally like finding a perfectly intact snowball sitting inside a blast furnace.
Okay, let's dive into the absolute center for Section 4, the blistering X-ray bubble. So, while that outer optical shell we were just talking about sits at a relatively cool 10,000 Kelvin, the XMM Newton Space Observatory revealed a shocking truth about the central cavity. It might look empty, but it is far from it. That inner cavity is actually completely filled with an invisible, shock-heated plasma bubble
That is burning at a blistering 2.35 million Kelvin. 2.35 million! It's an unbelievable jump in heat. At that extreme temperature, the gas doesn't even emit regular visible light anymore. Instead, it radiates powerful, high-energy X-rays. To figure out how this all fits together, researchers use this advanced 3D modeling software called SHAPE. They took all that X-ray data and matched it up perfectly with the optical imaging. And it proves that this super hot, highly pressurized bubble is the exact engine driving the inner shell's expansion. The high-pressure plasma is physically pushing the cooler gas outward, basically inflating the entire nebula like a giant glowing balloon. Let's pull all the way back out again for Section 5, Rings in the Halo. Way, way out in the giant, asymmetric outer halo, deep imaging has actually revealed these mysterious, faint, broken concentric rings, along with a couple of arc-like features. It's highly likely that these rings were shattered and deformed when those high-speed interjets we talked about earlier originally punched right through them. It's essentially a permanent record of a violent past written directly into the gas. When we map it all out, it brilliantly illustrates the timeline of the star's death. It shows how the really gentle shedding of those rings tens of thousands of years ago slowly evolved. Then the outer shell formed about 5,400 years ago. And finally, it all culminated in those violently fast jet ejections just a few hundred years ago. It's just a complete chronological map of stellar death. Now, why does any of this matter? What's the big takeaway for us here? Well, it's the nature of the star at the very center of it all. The progenitor star that created this entire massive spectacle was actually incredibly similar in mass to our very own sun. Which leaves us with a kind of haunting final thought. As we gaze out 4,000 light-years away at the incredible, chaotic complexity of Caldwell 59, are we simply looking into a cosmic mirror at the ultimate beautiful fate of our own solar system? It definitely makes you look at the sky just a little bit differently, doesn't it? Thanks for exploring the ghost of Jupiter with me, and as always, keep looking up.